Alright guys, so today's video is going to be about basic constructions and specifically about the angle bisector. Unfortunately, because we are in an online format, we're not able to do all the actual constructions with a compass and a straight edge that I would like to. Of course, if we were in person, I would definitely show you how to use a compass and straight edge, but anyway, that's the case, so we're not going to get to actually do one, but you're going to have to know how to use the property of an angle bisector to solve some problems, okay? So let's look at that. So the one we're going to focus on today is an angle bisector. So an angle bisector is a ray that divides an angle into two congruent coplanar angles. Its endpoint is at the angle vertex. Okay. Now what I'm going to do is on this program I'm able to make a compass. Okay, and I'm going to demonstrate what we would do if we were in class on actually how to make an angle bisector, just because it's the only one we're going to work with today. So first thing I'm going to do, make sure I'm on the pointer, is I'm going to open this a little bit, and then I'm going to move it so that the point, now if you're not familiar with a compass, one side is a needle or a point, the other side has the pen or the pencil on it. So I'm going to move and make sure my needle is on the vertex. Okay, and now I'm going to draw what's called an arc. Okay, let me move this out of the way. So compasses are used to to construct arcs, circles, and different geometric figures, okay? So first thing I did was I opened my compass and I set the needle on the vertex and I drew an arc that intersected both sides of my angle. Okay, so now notice that we've got an intersection point here and here. I'm going to put my compass needle on both of those, on one of those intersections, and then I'm going to draw a piece of an arc. Okay, then I'm going to move it down to the other intersection mark and then draw another arc. Okay, and I'm going to scoot this out of the way. So the goal is we're trying to bisect this angle. Now bisect means to cut it in half, basically. Okay, so we're taking this entire angle's measure and we're cutting it in half. And this compass is helping us to do that. So now what I'm going to do is see how those two arcs I made here intersected right here, somewhere inside this angle. So I'm going to make me a ray. I'm going to start at my vertex and make it go out and make sure it goes through that intersection. Okay? So basically what I've done is I've taken my big angle and I've kind of cut it in half, and each piece is half of it. So let's say this big angle was, I don't know, 60. Each little piece right here would be 30. Okay? Now, I gotta trade places for a minute because I did this at my computer. Now I'm going to transition to the board so I can actually do some work. Okay, so give me just a second. Alright. Move on. So here's the work you're going to see with angle bisectors. So this first example, let's read the problem, okay? Let's get this down. So ray MO bisects angle LMN. Okay, so let's look at our picture. LMN is our big angle. This ray MO is our angle bisector. Okay? They tell us that the measure of angle LMN, so LMN, is 6x minus 30. The measure of angle LMO is x plus 35. Here's what we're asked to do. Find the measure of angle NMO. So this example problem is to So this example is how you're going to find a piece of the big overall angle, right? And to solve this, we're going to use our angle addition postulate that we learned last week, okay? So because it's bisected, I'm going to write out what we're solving. The measure of angle LMO plus the measure of angle, I didn't remember how they said it, NMO. Equals the measure of angle LMO. That is the angle addition postulate, right? So let's label what we know. We know what LMO is. That's going to be x plus 35 plus. Now, they didn't tell us outright what NMO is. Okay, we have to find that. But we know that this big angle has been bisected, which means that this small piece is congruent or the same measure as that small piece. Okay, so if LMO is x plus 35, that means that NMO is also x plus 35. Okay, and they told us that oops, I wrote this down wrong. Hang on just a second. LMN. Sorry, just realized I wrote that down wrong. Okay, LMN is 6x minus 30. Alright, we need to combine like terms. We got 2 x's plus 70 equals 6x subtract 30. Okay? I'm going to move this smaller x just because that's how I roll. I like to keep it positive. So subtract 2x. 7 equals 4x minus 30. Now I want to add the 30. 100 equals 4x divide 4. 100 divide 4 is 25. Yay, I'm done, right? I got the x. Is that what I'm asked? Is that what I was asked to find? Let's go back and look. Find the measure of angle measure of angle NMO. Okay? Remember, NMO was this expression x plus 35. So we have to now the measure of angle equals x plus 35. Subbing our 25. And we get it to be 60 degrees. Make sure you put that degree symbol on there because we're talking about an angle measure. Okay? That's basically it. It's not super hard. You're going to set up an equation using that angle addition postulate, plug in what you know, solve the equation, and you'll either be asked to solve for x and then stop here, or you have to go plug it into a specific angle measure. Okay? That's the first example. Let's go on to the second one, which coincidentally is the last one. Let me change colors here. Alright. Setup is similar. The ray MO, so this ray right here, is bisecting the angle LMN again. They tell us that the measure of LMO, so this piece right here, is 6x minus 22. And NMO, the other small piece, is 2x plus 30. Okay? Solve for x. Now, I know what we're doing. We solve for x and find the measure of angle LMN. What's LMN? LMN. That's the big angle. They want us to find it. Okay? Two things. Solve for dx, plug it in to get LMN. So, let's set up an angle addition postulate problem. So we got the measure of angle LMO plus the measure of angle NMO equals the measure of angle LMN. Alright? That's what we have to do. Now, let's go back to our diagram. Looking at that blue equation I just wrote, I know nothing about the measure of angle LMN. Okay, so I can't use this blue one just yet. Okay, switching colors. What I do know is that because angle LMN is bisected, this expression and this expression have to be the same. Okay, so this example, it's all about using the pieces to get the whole angle measure. Alright, so I'm going to use those pieces. It's bisected, which means those expressions are equal. So I'm going to set 6x subtract 22 equal to 2x add 30. Okay, move the small x. Oops. Go over. 4x subtract 22 equals 30. Add the 22. 4x equals 52. Divide. X equals 13. Okay, so there is what x equals. Now, we've done this part. Now we have to find the measure of LMN. Well, LMN is going to be these two small pieces added together. So what I'm going to do is take my x that I just found and substitute it in for the x's in both of these expressions. Alright? So, whoops. Six times, I forgot what my x was. Ah, that's funny. 13. And you type that in your good old calculator, you should get 56. Whoops, wrote that in the bad spot. Hang on. The measure of angle NMO equals 2x plus 30. So plug in 13. That's also 56. Because 2 times 13 is 26, add 30 is 56. Now, from this point, we know we solved for x correctly because both those pieces match. Okay? And they have to match because we're bisected. Now, to get the big angle, LMN, we simply take our two 56s and add them together. And if I can do math correctly, should get 112 degrees. Yeah. Alright. Double check if I need to say anything else. Okay. Alright. That is how angle bisectors work. You will either set the two small pieces equal to each other and solve for x and do something with x, or you could go back to this first example and you'll use a piece, a small piece, and the whole piece to find something else, okay? It just depends on how the problem is worded. Okay? On your homework, there's only 5 problems. You're welcome. Only 5 problems. So 1 through 2, look at example 1, 3 through 5, look at example 2. Okay? And I'm going to caution you on number 3. Number 3 will say set up an expression. That means you set it up, but you do not solve it. Okay? Just set up what you would do in order to solve it, but don't actually solve it. Okay? Alright, that's all you need to know for angle bisectors.